So let us begin with some more properties of Noetherian modules. So yesterday I told you about Noetherian modules and Noetherian rings. Then I also talked about left Noetherian rings and right Noetherian rings. And similarly for Artinian modules and Artinian rings. And then there are counter examples in each case. And have you tried to construct those counter examples? Kia?
यस मैम मतलब ट्राई किए थे
Okay,
करने
so
के
do you
मैम पर लेफ्ट एंड राइट वाले केस जो है ना
uh-huh.
जैसे लेफ्ट नथीरियन राइट नथीरियन उनके एग्जांपल्स करवा दो वो उसमें नहीं सोचा जाता मतलब लेफ्ट राइट
Socho,
वाले में
Socho, you have a lot of resources with you. You can search the internet, you can look up books. So, थोड़ा you get the material and then I'll do it with you. आप लोग लेकर आओ कोई examples. ठीक है? थोड़ा you can search up the word, third sector, and then that way that will help you. Okay? So I will begin with some more examples of some more features of Noetherian modules. One of the important feature of a Noetherian module is the following. So let M be R module. Okay, then this theorem says that M is Noetherian if and only if every submodule of M is finitely generated. This is one of the most important results which you use throughout to prove that certain module is Noetherian. You prove that all its submodules are finitely generated. That this will prove that the module is Noetherian. This is the first result which you prove when you study Noetherian modules. What does its proof? Can you give me the proof? You've already done it. This is just a revision. Suppose
If there
यस
is an
मैम
infinite chain in a submodule, then it will be infinite in the module also.
say
So,
it again,
अगर
say it
हमें
again.
contradictions है,
Say it again. I know
मैम
M is a Noetherian R module, and then I want to prove that every submodule of M is finitely generated.
मैम अब अगर हम कॉन्ट्रडिक्शन से प्रूव कर दें इसे सपोज कर लें कि इसका कोई सब मॉड्यूल है विच इज नॉट नोएथेरियन तो
Which
उसमें
is
एक
not
चेन
finitely
मिलेगी
generated.
इनफाइनाइट
See, what I want is that suppose M is Noetherian, and we want to show that all submodules of M are finitely generated. This is what I want to show. Take a submodule up bolo. Let N be R submodule of M. Ab bolo, I want to prove that N is finitely generated. Now give me the proof. ठीक बोलो.
मैम हम ऐसा कर सकते हैं कि हम एक कलेक्शन ले सकते हैं फाइनाइटली जनरेटेड मॉड्यूल्स की
हाँ.
अगर उसमें एन क्योंकि हमने बोला है कि एन जो है वो फाइनाइटली जनरेटेड अगर नहीं है तो एन उसमें नहीं होगा पर क्योंकि एम नोथेरियन है तो उस कलेक्शन का कोई मैक्सिमल मॉड्यूल होगा मैक्सिमल एलिमेंट होगा मान लिया वो एन नॉट है अगर एन उस एन नॉट के बराबर नहीं है तो एक्स ऐसा होगा जो एन में होगा पर एन नॉट में नहीं होगा तो उससे हम एन नॉट प्लस आर एक्स एक नया मॉड्यूल सब मॉड्यूल जनरेट कर सकते हैं पर क्योंकि एन नॉट फाइनाइटली जनरेटेड है उसके साथ एक्स से जनरेट किया है तो वो भी फाइनाइटली जनरेटेड हो गया बट एन नॉट मैक्सिमल एलिमेंट था और एन नॉट प्लस आर एक्स उससे बड़ा हो गया तो फिर वो कॉन्ट्राडिक्शन हो जाएगी तो एन को
समझ नहीं
भी
आ रहा
उस
है. Say
कलेक्शन में
it
करना
again. Say it
पड़ेगा
again. Say it again. Say it again. I want to prove N is finitely generated. हाँ बोलना अपना proof. Say it again.
consider collection of finitely generated modules submodules of M
finitely generated, this is the collection of finitely generated R submodules of M. Okay. Okay.
अगर अब हम suppose कर लेते हैं, suppose that if n is not finitely generated,
Okay. If N is not finitely generated, then
क्योंकि m नोथेरियन है तो उस सिग्मा का एक मैक्सिमल एलिमेंट होगा,
okay. Sigma has maximal element. Okay.
say n naught,
Say N naught.
क्योंकि n finitely generated नहीं है तो n naught is not equal to n,
N naught is not equal to N because N is not finitely generated. Okay. Then
so there exists x belonging to n such that x does not belong to n naught.
there exists X belonging to N such that X does not belong to N naught.
n naught. अब हम n naught plus rx एक नया सब मॉड्यूल कंसीडर कर लेते हैं m का.
Okay. What will happen if N is contained in N naught? What will happen in that case? Then you cannot pick this. Hannah, in this case, how will you pick this?
मैम अगर हम ऐसा लें कि let n be a submodule of m which is not finitely generated, तो n is equal to like a1 a2 up to a3 जैसे
N
उससे
is
जनरेट हो रहा
not
है.
finitely generated. Okay, N is like, हाँ बोलो.
a1 a2 a3 उससे जनरेट हो रहा है.
A1, A2, A3 से generate हो रहा है. मतलब मैं समझी नहीं. N is not finitely generated. हाँ. नहीं, I didn't get this point that N is generated by A1, A2, A3.
मैम A1R plus A2R plus A3R up to so on उसका because वो finitely generated नहीं है तो ये ऐसे represent हो सकता है.
हाँ, मतलब कुछ आइडिया ठीक है. शुरू में अनिष्का कुछ बोल रही थी. कैन अनिष्का स्पीक समथिंग? तो फिर आती हूँ मैं. This something here.
I got the statement of the theorem wrong. I thought the result was every submodule of M is also Naderian.
Okay, all right. Okay. So there is something here which you can work out. So see, I have an R submodule of M, and what I want to prove is that R is finitely generated. Okay. So we want to show that R is finitely N is finitely generated R module. Okay. So what will you do? So take x1 the way Harleen was taking. Take a1 in N. Okay, and look at R a1. I am just keeping R on the left. Left R submodules. I am more comfortable with left modules. So R a1 is contained in N because this is a1 is an element of N. So anything this multiplied with elements of R is contained in N. Okay. So if RA1 is equal to N, then N is finitely generated because it is generated by A1 as R module, it is generated by A1. Okay. ठीक है. If not, if RA1 is not N, then choose A2 belonging to N and A2 not in RA1. ठीक बात है. Now consider RA1 sum RA2. ठीक है? So I have taken A2 which is here but not here. If this is not equal to this, it means this is properly contained in this. Okay? So you pick this. Now this fellow is contained in N because A1 and A2 they are both in N, and RA1 plus RA2 is also contained in N. If equality holds, then N is finitely generated by A1 and A2. If not, continue. So what will you get? You will get RA1 properly contained in RA1 plus RA2, properly contained in RA1 plus RA2 plus RA3, and so on. But this chain has to stop somewhere. See, if this is not equal to this, I will not have equality here. If this is not equal to this, I will not have equality. This chain cannot go indefinitely. Therefore, this chain has to stop, and therefore somewhere you will get that RA1 sum RAK is equal to N for sum K. Otherwise, if this does not happen, this chain will go infinitely up. But that is not so, because you cannot have an infinite ascending chain of R submodules of M. Is that okay? You had, Harleen, you had this in mind only, or you had something else when you were pointing out these A1, A2, A3 and so on?
Ma'am, I was using another definition of Nadirian, that each submodule of M will have a maximal element.
Each submodule of M will have a maximal element. No, each collection of submodules of M must have a maximal element.
Okay, ma'am.
हर सबमॉड्यूल का मैक्सिमल एलिमेंट नहीं है. हर सबमॉड्यूल के मैक्सिमल एलिमेंट की तो आप बात ही नहीं कर सकते ना, बिकॉज यू डोंट हैव अ पार्शियल ऑर्डर ऑन एन. एन के अंदर तो कोई पार्शियल ऑर्डर नहीं है ना मेरे पास.
Yes, ma'am.
I have an order on the
होगा.
submodules. I have a partial order on the collection of submodules, and the order is containment, that one submodule is contained in the other submodule. But I don't have any partial order on elements of n. I cannot compare two elements of n. No way to compare two elements of n. I can compare the submodules. Which one is bigger, or which one is contained in which one. Okay. So
Yes,
if M
ma'am.
is a Noetherian module, then every submodule of M is finitely generated. And next, conversely, so let us prove that suppose all submodules of M are finitely generated, then I want to prove that M is, ab bolo mere ko proof. We want to show that M is a Noetherian R module. So what will you show? What do you need to show that it is a Noetherian R module? Take an ascending chain of R submodules, show that it must stop. Okay? How will you do that? Any clue?
Taking a chain of मैम इसमें अगर हम एक चेन ले लें और ऐसे करते जाएं, देखते जाएं कि एलिमेंट्स स्ट्रिक्ट, अगर स्ट्रिक्ट इनइक्वालिटी होगी तो M2 में एलिमेंट होगा जो M1 में नहीं होगा. मैम ऐसे ऐसे करते हमें एलिमेंट्स मिलते जाएंगे किसी मॉड्यूल में और वो फाइनाइटली जनरेटेड नहीं रहेगा.
कौन सा मॉड्यूल फाइनाइटली जनरेटेड? मेरे को इतना पता है कि ये सारे फाइनाइटली जनरेटेड हैं. मतलब ऐसे कैसे कह सकते हो कि इसमें कुछ मिल गया जो इसमें नहीं है, इसमें कुछ मिल गया इसमें नहीं है, then this module will not be finitely generated. No, you just can't say that. Look at this. Look at Rx1 contained in Rx1 plus Rx2 contained in Rx1 plus Rx2 plus Rx3. So you're taking those x1 x2 in such a way that x2 is here but not here, x3 is here but not here. So you're getting this. You see, if you have a chain of submodules, what you take their union. Take their union. Let n be the union of all the mi's. Take their union. In general, union of submodules is not submodule, union of subgroups is not subgroups, union of subrings is not subring, but in the case of this ascending chain, this union is a submodule. You can show that. Arbitrary union is not, but because of this chain, this union is our submodule. Can you check this?
Yes, ma'am.
Is that okay? Is that clear to you? Okay, but n is finitely, because every submodule of M is finitely generated. By hypothesis, n is finitely generated. Okay. So n is like Rx1 sum Rxk for some x1 x2 xk in n. Okay. ठीक है ना? नहीं? Is that okay?
Yes, ma'am.
So now these xi's belong to the union of mi's. Xj's belong to the union of mi's. So but this is an ascending chain. So there exists L such that all the x1, x2, xk belong to ml. है ना? Because x1 is in one of the mi's, x2 is in one of the mi's. So take the biggest one. So at some large stage, you will have all the xi's in some ml. Okay. Suppose x1 is here, x2 is here, x3 is here, x4 is here. So take the largest one, जिसमें सारे आ गए. Okay. So
मैम
Yes, ma'am.
क्योंकि ये यूनियन हमने 1 to infinity ली है, मतलब जैसे हमें नहीं पता कि अभी फाइनाइट है कि नहीं, टर्मिनेटिंग चेन है
this
कि
is
नहीं,
an
तो हमने
infinite union.
n को
Infinite.
यस मैम, तो हमने n को फाइनाइट आर लीनियर कॉम्बिनेशन में कैसे लिख लिया? n फाइनाइटली जनरेटेड, मतलब हमें कैसे पता कि वो फाइनाइटली होगा, क्योंकि m's तो अभी हमने देखे कि इनफाइनाइट है, तो हम सीधा n
No.
को
My
finite
hypothesis is that, see, I'm proving the converse statement. My statement is what? Every submodule of M is finitely generated. I'm given this. I want to prove that M is finitely generated.
हम ठीक है, वो यूनियन सब मॉड्यूल लेके थी.
ठीक है ना?
हाँ जी, हम ठीक.
So I'm given that N is finitely generated. I'm given every R submodule of M is finitely generated. So there is a L such that this. Okay. So now this chain will stop after that. Now N is contained in ML, but ML is contained in N, because N is the union of all the mi's, therefore N is equal to ML. So what does it mean? Their union is this. Their union is this. This is your ML sitting here, and the union is this. That means after this chain stops ascending. Therefore, NL is equal to NL plus 1 and equal to and so on. Because all of these are contained in N. All of these are contained in N. And N is contained in this. Therefore, N is contained in all of them. Therefore, all of them are equal to N. Okay?
Yes, ma'am.
So that is this is a very basic result in Noetherian modules. Many a time, if you want to prove that a module is Noetherian, then see, it is difficult to show that every ascending chain must stop. So several places you cannot use this definition. So at certain places it is easy to see that every submodule is finitely generated, and therefore you can see that this module is Noetherian. Okay. So as you said, Z as Z module is Noetherian. Because what are submodules? Submodules are just NZ which are finitely generated. Therefore, it's a Noetherian module. Okay? Is that all right?
Yes.
Okay. So this is one thing which is very frequently used, that a module is Noetherian if and only if all its submodules are finitely generated. Then another theorem which is used very frequently is the following. Do you know exact sequences? Last semester you have done exact sequences, but I don't know whether that happened before the lockdown or after the lockdown.
Last to last
Yes.
in first semester.
In the first semester, okay. Then you know. Okay, so you have an exact sequence of A modules. Okay, so let 0 M dash to M double dash to 0 be an exact sequence of R modules. Then M is Noetherian if M dash and M double dash are both, of course, R modules. आप मेरे को जरा can you recall what do you mean by exact sequence of R modules? Okay, let me write F here and let me write G here. That makes more clear to you. What do you mean by exact sequence of R modules?
Ma'am, if image of F is equal to kernel of G, then we say that it is exact.
Image of F is kernel of G, F is 1, 1, G is on 2.
Yes, ma'am.
Okay, so this means exact sequence of R modules means F is 1, 1, G is on 2, image of F is kernel of G. Okay, so F is 1, 1 means that in M you have a submodule isomorphic to M dash, है ना? And this is on 2 means M modulo M dash, M modulo the image of M dash is isomorphic to M double dash. So essentially, M is an R module. So in this R module, you have a submodule M dash, and M mod M dash is isomorphic to M double dash. So if this happens, then this is an exact sequence. Okay? All right. All right. This is not rubbing. All right. So can you give me its proof? So essentially, I can also similarly for Artinian, the same thing is for Artinian, but I will just prove it for Noetherian with you, and then Artinian proof you can do it yourself. All right. So M is Noetherian. Suppose M is Noetherian, and we want to show that M dash and M double dash are Noetherian. ठीक है? Any clue? Use the last result. You see, M dash is isomorphic to Fm dash because F is 1, 1. F is 1, 1. M dash is isomorphic to its image. है कि नहीं?
Yes, ma'am.
नहीं, ये थोड़ी हल्की है. क्या बात, कंफ्यूज हो गए?
नहीं मैम ठीक है, F11 है तो हम बोल सकते हैं.
Okay. So M dash is isomorphic to this, and Fm dash is a submodule of what? Of what?
Of M.
M.
All right. M is Noetherian. So if M is Noetherian, then Fm dash is also Noetherian. So one of the results which follows from the previous results is that a submodule of a Noetherian module is Noetherian, because M is Noetherian means all submodules of M are finitely generated. So in particular, all submodules of Fm dash, they are submodules of M, they are finitely generated, therefore Fm dash is Noetherian. Is that okay? All submodules of M are finitely generated because M is Noetherian. Okay? Therefore, any submodule of Fm dash being submodule of M is finitely generated. So all submodules of Fm dash are finitely generated. Therefore, by last result, Fm dash is Noetherian R module. है कि नहीं?
Yes, ma'am.
But up to isomorphism, if this is Noetherian, isomorphic module is Noetherian, I will leave it to you. So consequently, M dash is Noetherian. Okay? All right. So next
Yes,
we want to show what? M double dash is Noetherian. What I have, M double dash is isomorphic to M modulo the kernel of G. G is on 2, okay? So M double dash is, use the fundamental first isomorphism theorem, M double dash is isomorphic to M modulo the kernel of G. But kernel of G is the image of F, but image of F is isomorphic to M dash because F is 1, 1. So this is M mod M dash, isomorphic to M mod M dash. Okay?
Yes, ma'am.
Now, look at, to show that M double dash is Noetherian, show that every R submodule of M double dash is finitely generated. I told you, this is the fundamental thing, most basic thing to use, that to show that something is Noetherian, show that all its submodules are finitely generated. Take a submodule of M double dash. Any submodule of M double dash is what? It's a submodule of this. It is like what? Is like I can use n. Okay, n modulo the image of f for a submodule n of m containing image of f. This is how submodules of the quotient module look like. Submodules of this module are n modulo the image of f, where n is R submodule of m containing the image. This is a correspondence theorem. How do you connect submodules of M with the submodules of the quotient module? This is how you get submodules of the quotient module. Take the quotient of the submodules of M that contain the image. Okay, but N is finitely generated because M is Noetherian. Okay, so if N is finitely generated, then N mod image of F is also finitely generated. So that's a easy exercise. So consequently, show that n modulo the image of f is finitely generated. Because if n is generated by say x1, x2, xn, then show that n mod the image of f is generated by image of f plus x1, image of f plus x2, and so on. Okay.
मैम इमेज ऑफ f प्लस rx1 होगा या x1?
x1 as R module, na? As R
Okay, ma'am.
it is generated by, so it is image of n modulo the image of f is R image of f plus x1 plus R image of f plus x2 plus, as R module it is generated by these elements. These are elements of n mod the image of f, and they generate this because n is rx1 plus rx2 plus rxn. ठीक है कि नहीं? Is that okay?
Yes, ma'am. Yes, ma'am.
All right. So this is only one way you have shown, but you can also show the other way round. Can you give me the proof of the other way round? That conversely, suppose n dash and n double dash are Noetherian. So then what do you get? N dash is isomorphic to Fn dash, and Fn dash is a submodule of M dash and M dash. Suppose M dash and M double dash are Noetherian. M dash is Fm dash. Okay? And M modulo Fm dash is isomorphic to M double dash. Now, this is Noetherian means this is Noetherian. This is Noetherian means this is Noetherian. Okay? So, Fm dash is R submodule of M such that Fm dash and M modulo Fm dash are Noetherian. ठीक है? So now you show that M is Noetherian. This is finitely generated as R module. This is finitely generated as R module. Show that this is finitely generated as R module. This is the question. Fm dash is finitely generated as R module. And M modulo Fm dash is finitely generated as R module. Say this is generated by x1, x2, xk, and say this is generated by fm dash plus y1 fm dash plus yk. Okay, now show that m is finitely generated. Give me a finite generating set of MSR module. Take an element of M, show that it is R linear combination of some finitely many elements. What are those elements?
y1 to yk.
y1 to yk. बोलो.
एक्सरसाइज की आएंगे
Yes.
एक्सरसाइज की होंगे.
Excise. नहीं समझ आई मेरे को. I didn't get your response.
मतलब हम ये कहना चाह रहे हैं कि जो m है वो x आइज और y आइज से जनरेटेड होगा.
आंसर सही है. मेरे को प्रूफ बता दो फटाफट. y1 y2 yk क्यों लिखा मैंने? दे मे बी डिफरेंट ना. 1 लेस देन और इक्वल टू j लेस देन और इक्वल टू. मुझे इसका प्रूफ बता दो. आंसर ठीक है फटाफट. यस. आई वांट टू प्रूव दिस.
कोई एलिमेंट m पिक करें.
हाँ जी, ये चीज मुझे शो करनी है. मैं लिख देती हूँ क्या शो करना है. हाँ, पिक करो कोई एलिमेंट. कहाँ पे पिक करूं?
m
टेक
स्मॉल m ले लें अगर
m. हाँ बोलो. यस. देन
अगर तो मैम वो fm डैश में हुआ
हाँ,
तो फिर तो वो x i से x i का लीनियर कॉम्बिनेशन हो
yes
जाएगा.
yes r के x के for some ri is belonging to r and so done. फिर हो गया बात. if not
तो मैम हम उसको m मॉड अगर fm डैश में उसकी इमेज देखें
yes
तो वो y i plus fm डैश
yes it is now say s1 y1 plus s नहीं लेती मैं. I will take something else. क्या ले लूँ? Say let me take a1 y1 as ys plus fm dash. Fm dash I'm writing on the left hand side, so let me write fm dash plus this. Do you get this? क्या रब करके लिखूँ?
है मैम ये
This is equal to fm dash plus a1 y1 plus as ys. as belong to r. ठीक बात है. अब क्या करूं?
fm डैश खुद ही फाइनाइटली जनरेटेड r मॉड्यूल है.
Yes, m minus a1 y1 plus as ys will belong to what? These
Dash.
two are same. fm dash. But fm dash is r module generated by xis. Okay. So m minus a1 y1 minus है यहाँ पे minus as ys is what? b1 x1 plus 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 bk xk for some bi's in R. So m is ulti side ले जाओ, m is a1 plus 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 this and you're done. हो गया. It is our linear combination of all the xi's and yj's. So m is contained in this, but all this is contained in m, of course, and therefore they are equal. Okay.
Yes, ma'am.
So therefore this gives you. So another way to state this theorem is that I can just write it like this, that let M be a Noetherian R module, then every submodule of M and every quotient module of M, quotient of M is also. And then I can also, from this, I can also conclude that suppose M is R module and N is R submodule of M such that N is Noetherian and M mod N is Noetherian, then M is Noetherian. These two things, I mean, in fact, what you have proved is equivalent to this corollary plus this corollary. See, going forward is this and going backward is this. Is that okay?
Yes, ma'am.
Because if you have a submodule of M, if N is a submodule of M, then I can construct this exact sequence. This is an exact sequence, and because M is Noetherian, therefore these two are Noetherian. Therefore N and M mod N are Noetherian. So every submodule of M and every quotient module of M is Noetherian. ठीक है ना? And if M is an R module such that N and M mod N are Noetherian, if N is a submodule of M and these two are Noetherian, then this is Noetherian. This is the converse of the last result which you proved. Okay, so this is this step of the last result, and this is the converse of the last result. You can equivalently state it like this. Okay.
Yes, ma'am.
Okay. Another consequence which you can draw is that direct sum of Noetherian modules are Noetherian. You see, the whatever you prove for Noetherian, the same thing, same results also hold for Artinian. I will leave that to you, so you can prove that yourself. Okay. So if M1, M2, Mk are Noetherian R modules, then so is their direct sum. Direct sum of MIs. How will you prove this? Use this result which you have done. कैसे करोगे? Apply induction and use the result. See, look at this.
For n equals to 2 के लिए करते हैं.
हाँ जी.
हम यही पहले n equals to 2 के लिए कर देंगे, फिर बाद में इंडक्शन.
बाद में इंडक्शन. अब मुझे बताओ, प्रूफ बताओ. कैन यू टेल मी? हाँ बोलो प्रूफ. So
एक एग्जैक्ट सीक्वेंस कंस्ट्रक्ट कर सकते हैं हम M0 से M1, M1 to M1